Oh, my screen's not even centered. All right. What up, guys? This is a quick little example problem coming out of Unit 2. So just a couple of bits about this. Normally this would be in words. I already drew out a picture just to make life easier. We have a red guy who's running 1 meter per second to the right. We have a blue guy running 3 meters per second to the left. And the question is, at what position and what time will they meet? You'll notice that they are separated by 40 meters. First thing, in order to help myself out, one of the things I'm going to do is I'm going to actually visualize this through a motion map. So in order to draw in a good motion map, I'm going to draw on my position axes, which I will label X for position, and I'm going to label my 0 meter mark exactly where my red guy is starting. And we'll talk about what this choice actually means, but you'll realize that I could have put my 0 meter mark really anywhere. And we'll talk about how that will change this problem. He is going to be running to the right at a very small velocity. You're going to notice in order to do that, I'm going to draw in these very small arrows to the right at a nice constant velocity like that. Then I'm going to do the blue guy. I'm sorry, I forgot one last thing. T equals 0, mark that, of course. And then the blue guy, starting over, now we know he's starting 40 meters away. And we're going to put him there, and we're going to have him moving to the left. And again, you'll notice the arrows are about 3 times as long because that's how fast he is traveling in respect to the red arrows that I drew in. And you're going to realize right away, just from my drawing, they're going to meet more towards here. They're going to meet closer to 0 than they are going to be meeting at 40. So you start to realize that it's going to happen there just from my drawing. The other thing that I want to draw in is, of course, a position versus time graph just to help out with my visual. So my position versus time graph, so again, X versus T, position versus time. And my blue guy is again going to start at the 40 meter mark, as we saw. So I'm going to make this 40 meters. And he is going to be running left with a negative velocity very quickly. And my red guy will be moving to the right slowly, starting at 0. And you're going to realize, again, they're going to intersect at some time, which we will call T, and at some position, which we will call X. All right, so from here, what we can do is we can write our 2 mathematical models. Our mathematical model for the blue guy is going to be at some position X. We know his velocity in this case is 3 meters per second times time, whatever his time is at that position X, plus our initial position, which is 40 meters. So if you're wondering where that came from, that actually came from our equations. X equals VT plus X naught. This was from last video. So if that confuses you, take a look at last video. That is an equation that we can get from a straight line constant velocity graph. If I wanted to do this for the red guy, I could do the same thing. Again, X equals some position X equals 1 meter per second times at some position T. And you'll notice I won't even have to put the y-intercept there because, well, it is 0 in this case. So I have these 2 equations. You'll also notice that I have 2 unknowns. They meet at that same position, same in this case, and then T's are also the same. So actually all what you have to do is you have to perform a substitution where we are going to just make those 2 equal to each other. So I'll do this in black just so the colors don't get too confusing. We have this equation equals that equation, so we have 3 meters per second times T plus 40 equals 1 meter per second times T, and you're going to realize that I made a mistake. Going back, of course, making mistakes, you can always learn from them. You're going to realize very quickly that I forgot something. In my original equation, the 3 meters per second times T, you're going to realize that there should have been a negative there indicating that the velocity is negative, thus we have a sloping line. So that should be a negative. And so now when I actually solve this, I'm going to try to solve it for T because, again, they share that T in common. And so all I have to do is add 3 meters per second to both sides. And you're going to notice that that goes away, and we're left with 40 meters equals 4 meters per second times t. And when we divide our t out, you're going to realize that divide by 4 meters per second, divide by 4 meters per second, those cancel out, and you're left with t equals 10. And double check the units. We have meters divided by meters per second, which is the same as meters times seconds over meters. You're going to notice that we get seconds out of that whole bit. So they will meet at t equals 10 seconds. So right away I get this as being 10 seconds. Excellent. Now the question is, at what position is that going to be? Well, because t is equal to 10 seconds, all I have to do is plug that into either one of these mathematical models. They should both give me the same answer. And you're going to realize if I did that, I'm just going to kind of squeeze it in on over here. If we did that, we have x equals -3, ooh, that should be a 3, -3 meters per second times 10 seconds plus 40 meters. Remember, a mathematical model is good to make these predictions. So at 10 seconds, where is blue going to be? Blue, x blue should be, well, we got -30 plus 40, which should be at 10 meters. And going to take a look at red, we could do the same thing. X is equal to 1 meter per second times t, which is 10 seconds. You're going to realize that that should also be 10. So our answer checks out. He should be at position 10 meters at time 10 seconds. So just kind of taking a quick little recap of what we have here. Biggest things are visuals. I know for some of you guys, you probably already knew how to do this, but those visuals will help you get an idea of what the answer should be. When we get into harder problems, the visual is going to be the biggest thing. So the motion map, the graphs, those things are going to really help us get a better understanding of how these problems work. If you have any questions, please ask. We will, of course, get more practice on this with Worksheet 3, which I believe we will start on Thursday. All right, guys, have a good one, and see you guys tomorrow.